This is Professor Antonio S. Marajas, and this is Advanced Digital Technique. Okay, so we go now to another type of flip-flop, and we call it the D flip-flop. So the D flip-flop is actually the improved version of your RS flip-flop. So the logic designer was able to eliminate the so-called race condition by placing an inverter in the input part, the R input of your RS flip-flop. So if you notice here that this portion of your symbol is the RS flip-flop. Okay? Now because of the race condition, logic designer placed an inverter here before your R input in order to eliminate the race condition. Okay? For example, if your D here is equal to 1, then the output of your inverter is 0. And S, since D here is directly connected to S, then S will be equal to 1. Okay? Then since inputs 0 and 1, or R and S are 0 and 1, and they have different values, therefore S implies Q, your Q becomes 1. So now, if D becomes 0, automatically your S becomes 0, while D becomes 1. So in this case, the so-called race condition is eliminated. Okay? And the final symbol for your D flip-flop is this one. So you have one input represented by D, which is this one, and then Q output and Q bar. Okay? So this will be your truth table. A very easy interpretation of the operation of the D flip-flop. We have, if D is equal to 0, Q will be equal to 0. And if D is equal to 1, then Q becomes 1, no? Because S implies Q. Why? Because D here is directly connected to your S. Okay? So if we will make a timing diagram of this, wala kayo tayong challenge, because if this is your D here, like this is your 1 area, 0 for D, then your output Q, if we want to draw the timing diagram for your output Q with a given D here, so the output Q will be the same as the value of your D, no? So it will be like this one. Mura lang siya copy-paste. Okay? So that will still be your Q. So whatever is the output, your input D, becomes your output Q. So wala ka tayo challenge diya. So we go now to the clock D flip-flop. This time, we have an input D and a clock as the controlling system of your D flip-flop. No? So your clock controls your D flip-flop. We have output Q and Q bar. Okay? And this is our truth table. If clock is 0, regardless on the value of your D, that means that whether it is 0 or 1, then the output is no change condition. Again, if clock is 0, regardless on the value of your D, then the output is a no change condition. But if clock goes to 1 and D is equal to 0, then D implies Q. Clock is 1, D is 1, D implies Q. So in other words, this truth table here can only be applied if there is clock. If clock, I mean, is 1. Okay? So, if this is the timing diagram for your clock, okay, this part here is 0, and this part here is 1 for your clock. Okay? So then, it goes down to 0. So this is the timing or the pulse for your clock. Or this is what we call the clock pulses, no? Okay, and that is where the clock receives its value. Okay, so let us apply this principle in our timing diagram again. So we have here our clock. This is our clock pulses. And we have here our input D. Okay. Now we want to obtain the output Q for the given clock and given D. So, again, if clock is 0, so for example, we start at 0 here, and clock is still 0 here, then that means that regardless on the value of your D, whether it is 1 or 0, the output is still a no change condition. So, since Q is 0, clock is 0, there will be no change condition. But when clock goes here, goes to 1, but still your D is equal to 0, then D implies Q. So your Q will still be equal to 0 until this area here is obtained. No? So your clock goes to 1, your D is 1, clock is 1, D is 1, D implies Q. So your output Q becomes 1. Here, your clock changes to 0. If clock is now 0 here, then D is equal to 1. It is a no change condition. So again, for as long as clock is 0, regardless of the value of your D, then the output is a no change condition. So it will remain as 1. No? Because the last value of your Q is 1, no change, that means that the output will remain as 1. Now in this case, your clock goes to 0, or clock is still 0, and your D is now 0. Okay? Again, for as long as clock is 0, it's a no change condition. So, 0 gap, 1 gapon siya diyan, no? Then here, clock is still 0, no change. But then here, in this particular area, clock goes to 1, D is 1, D implies Q, so D is still 1. But when it reaches this particular area, your clock is 1 and your D is now 0, then it goes down to 0. Okay? Here, clock is 1, D goes to 1. So D implies Q, so your Q becomes 1 again. Then, clock is 1. In this particular area, 1, then your D goes to 0. D implies Q. Clock is 1, D 0, 0. Like that. Then, here, your clock goes to 0. As long as clock is 0, no change condition. Then, here, clock goes to 1. D is still 0. The output remains 0. That will be your Q. Your Q bar will be just the opposite of your Q. So, if Q starts at 0, so Q bar will start at 1. It will go down, then it will go up, then go down, then go up. So that will be your Q bar. Again, how do we arrive with your Q here? So we start at 0. Okay? Then when clock is still 0, your D is 0, regardless of the value of your D. For as long as clock is 0, the output is no change. So if we start at 0, there will be a no change condition. Here, when clock goes to 1, then we will apply this table here. If clock goes to 1, whatever is the value of your D, in this case 0, so your output is 0. So from 0, it remains 0. And then, until it reaches this particular area, 1, 1. So 1, 1, D implies Q, so your output Q becomes 1. In this case, your clock goes to 0, no change condition. Here, 0, no change condition. Here, clock goes to 1, D is 1, still 1. Then here, clock goes to 1, D 0, D implies Q, 0. Then, clock goes to 1 here, D is 1, so nag-1 na po na ito ang output Q. And then, here, your clock is 1, your D is 0, it goes down to 0. Then, here, clock goes to 0, no change. Clock goes to 1, D is 0, so output remains 0. So that will be your timing diagram for the clock D flip-flop. By the way, the clock here, we will be using the 555 timer for our experiment in representing the clock. We go now to edge-triggered D flip-flop with preset and clear. So let me clarify the word edge-triggered. Okay, now, this means that your flip-flops here will be triggered by either the positive or the negative edge of the clock. No? So, if this is your clock, for example, your clock pulse, okay, now this part here is what we call the positive edge of the clock. And this one here is what we call the negative edge of the clock. Okay? So, in this particular case, in symbol A, for example, this one here has a positive edge triggered D flip-flop. No? So, what's the symbol for a positive edge clock? This one here, a triangle. This means that this particular symbol is controlled by a positive edge of the clock. Okay, the triggering of your output depends on the positive edge of the clock. So how about the preset here and clear? The preset and clear actually provides us with the information on our initial Q. Whether Q will start at 1 or Q will start at 0. In our previous discussion, we just assumed that Q starts at 0. But this time, with the presence of your preset and clear, we will be able to identify exactly where we will start, what will be our initial Q. Okay? So, let's have a table on this particular symbols here. So, again, this is a positive edge triggered D flip-flop with high preset and clear. This is your preset here and this is your clear. Okay? So, this is the symbol for a positive edge triggered D flip-flop with high preset and clear. And this will be our truth table. Okay? So, we have the clock, the D, and of course your Q. Okay, now it says positive edge of the clock. So in other words, if clock is 0, regardless on the value of your D, the output is no change condition. If clock is 1, regardless on the value of your D, the output remains no change. But if the clock goes negative edge, that is, negative edge is what? Going down. Okay? So that's the arrow going down. So if you have negative edge, regardless on the value of your D, the output will still be a no change condition. But when the condition is positive edge, as what we have here in our symbol, that will be this one. So, if D is equal to 0, then D implies Q. If there is positive edge triggering, and then D is 1, then you have D implies Q. So in other words, the triggering of your output here depends on the condition of your clock. Again, if clock is 0, regardless of the value of your D, whether it is 0 or 1, the output remains as a no change condition. If clock goes to 1, X, D is X or 0 or 1, the output remains as is. If clock is negative edge, this one right here, okay, this one here is positive edge, this one here is negative edge. Negative edge, regardless of the value of your D, then the output remains no change. Now, if there is positive edge triggering of the clock, and D is equal to 0, then that's the time that your Q becomes 0. Okay? Now, again, the positive edge here is being identified by this particular symbol, that is your triangle. Okay? So, that is for the positive edge triggered D flip-flop with high preset and high clear. Now, asa man mosulod ang preset o ang clear? Now, if we will use preset, basically, high preset man siya, so the preset should have a value of 1. Okay? Then, that's the time that we can say that your initial Q will start at 1. Okay? If we are using preset. So, in this case, since preset is equal to 1, then the initial Q here, that will be above here, that will be equal to 1. That will be our initial Q. No? So, Q here will have an initial which is equal to 1. So, in other words, the timing diagram later on will start at 1, not on the 0. Now, however, in this particular symbol, if we will use clear, what will be the value of clear? Clear should be equal to 1 again, because the symbol says it's high, preset, and clear. Okay? You have high, preset, and clear. Therefore, clear will also have a value of 1. In this case, if we are using clear, then that means that the initial value of your Q will be 0. So, your preset and clear, if we use preset, then we are having an initial Q equal to 1. But if we will use clear, we will have an initial Q equal to 0. So in this case, we're using clear is equal to 1. That means that our initial Q will be equal to 0. In other words, our timing diagram will start at 0, okay? And then the next output will depend on the condition of your clock and your condition of your output Q. That is for your symbol A. How about for symbol B? What will be our truth table? So, again, we have clock, we have B, and we have our Q. Okay? Now, what is this symbol? The symbol says that this is a negative edge triggered D flip-flop. The negative edge is symbolized by this one here. You have a triangle and a bubble. If you see this one, that means that it is a negative edge triggered D flip-flop. Okay? With high, preset, and clear. Parehas na yapon sa condition diri. Ang kalainan na sa duha is this one here is positive edge, this one here is negative edge. Okay? So, again, if clock is 0, regardless of the value of your D, the output is no change condition. Okay? Now, if your clock is 1, then again, X, regardless of the value of your D, the output is in no change condition. The X here will have a value of either 0 or 1. Then, if clock goes to positive triggering, since our symbol here is negative edge, regardless again of the value of your D, then the output will be a no change condition. But, if the clock now goes to negative edge, and that is this one here. Okay? Then, D implies Q. No? So, negative edge, D is equal to 1, then 1. That would be your truth table. So we have here symbol C. Okay? So symbol C says this is a symbol for a positive edge triggered D flip-flop with low, preset, and clear. Now this time, low, preset, and clear symbolizes by these particular bubbles here. Okay? So if you saw a bubble on the preset and clear, that means that it is a low, preset, and clear. Okay? So we have here the truth table again. So you have the clock, the D, and then you have your output Q. So again, if clock is 0, then regardless of the value of your D, the output remains no change. If clock goes to 1, regardless of the value of your D, whether it is 1 or 0, the output is a no change condition. If the clock goes negative edge, that is this one here, then regardless again of the value of your D, then the output will remain a no change condition. But if it is positive edge triggering, that is this one, then D implies Q. If D is equal to 0, then your output Q will be 0. Positive edge triggering, D is 1, the output is 1. Again, your preset and clear here will be used again to identify the condition of your initial Q. Okay, so again, if we will use preset, then our Q, initial Q, will start at 1. If we will use clear, our initial Q will start at 0. In this case, we have low, preset, and clear. So we have to provide a value of preset, which is in this case 0, because we're considering the condition low, preset, and clear. Unlike in this case here, you have high, preset, and clear. The preset and clear will have a value of 1. By the way, you can only use one of these preset and clear. Whether you use preset or you use clear. Isa lang ang gamiton. Dili pwedeng dunganon ng duha. So, if preset here is equal to 0, okay, then we will start our initial Q at equal to 1. Okay? In our timing diagram later, if we will use preset, then our initial Q will start at 1. So, this is for our symbol C. For our symbol D, this will be our truth table. Okay, again, what's this symbol? It is a symbol of a negative edge triggered D flip-flop. Okay, with low, preset, and clear. Okay, so again, you have the clock, you have your input D, and you have your output Q. So if clock is 0 again, regardless on the value of your D, the output is no change. Clock is 1, this X, output is no change. If clock is positive edge triggering, like that, regardless of the value of your D, the output remains no change. But if clock goes negative edge, okay, so since our symbol here is negative edge, if D is equal to 0, then the output is 0. If you have negative edge, D is equal to 1, then the output is 1. Okay, again, the initial Q will be determined on whether we use the preset or the clear. So if we will use clear, clear should be equal to 0 in this case, then that means that our initial Q will start at 0. But if we will use preset equal to 0, why 0? Again, because it is low, preset, and clear. So if we use preset, then our initial cue here will start at 1. So that is how we interpret the symbol. Let's have here an example, no, on how to draw the timing diagram for this particular timing diagram. Or we want to obtain the output cue for this particular timing diagram. Okay, so what we have here is a positive edge triggered D flip-flop with high, preset, and clear. So let's say, for example, we use preset here. Okay, equal to 1. That means that our initial cue will be equal to 1. Okay, so that will be our initial cue. So we have here the clock pulses for our clock, and then we have here our input D, no? The D pulses, or the value of your D input, and then we wanted to obtain the timing diagram or the output of your cue. Okay, so we have here preset is equal to 1. That means that we will start at 1. Okay, and then we find the positive triggering of the clock. Where are the positive triggering of the clock? So we have here this one, this one, this one, this one, this one. These are the positive edge of the clock. Okay, so again, this symbol here depends on, or the triggering of the symbol depends on the positive edge of the clock. So in this case, again, if Q is equal to 1 because of the preset, so we start here at 1, and then we find the positive edge of the clock. And what is D? D is equal to 1, so it remains 1. D implies Q during this positive edge triggering the clock. Clock is 1 or 0, then the condition is a no change condition. So 1 yapon siya. Now in this case, clock, we have here positive edge triggering of the clock. D is equal to 1. The output Q remains 1. Then we have here positive edge triggering of the clock. Okay? Positive edge triggering of the clock. Your D is equal to 0. Then your output Q becomes 0. Then we go to positive triggering here. Positive triggering of the clock. Your D is 0. So it will remain 0 up to this particular area. Then positive triggering here. Just find the positive triggering of the clock and then determine the value of your D. Then D implies Q. So in this case, positive triggering, D is 1, so D implies Q. Okay? Then here, positive triggering, D is 1, so it remains 1. Then, positive triggering here, D is equal to 0, then D implies Q, 0. Okay? Then, wala naman kay positive triggering, then remains 0. So that will be your timing diagram for this particular input D. Okay? So this will be your output Q. Your Q bar will be simply the opposite of your Q here. So if it starts with 1, so your Q bar will start at 0. Then, nag-0 siya. So your Q bar will go to 1, and then at 1. Okay, so that will be your Q and Q bar. Okay, so however, if we will use clear instead of preset, if clear here is equal to 1, then that means that our initial Q will start at 0. Okay, so your Q here will start at 0. Here, that will be this one here. And then we try to find positive edge triggering. Positive triggering, D is equal to 1, and that's the time that your output Q becomes 1. Okay? So, the same gyapon ang iyahang timing diagram. In other words, it will only differ on the initial cue. Okay? If we use preset, then it will start here. If we use clear, it will start here. Okay? So, mora ni siya ang difference. This particular area for preset and this particular area for clear. Okay? So, that is how we obtain the timing diagram for this particular symbol. Let's have another condition of your symbol here. And then we will try to determine the output Q and Q bar for this particular value of your D. Okay? So, our symbol here says that it is a negative edge triggered D flip-flop with low, preset, and clear. Okay? Now, let's say we use preset. So, since this is a low, preset, and clear, preset should have a value of 0. Therefore, since we are using preset, we will have an initial Q equal to 1. Okay? Then, we consider the negative edge triggering of the clock. Where is the negative edge trigger of the clock? This one here. These are the negative edge of your clock. So, that is where we will base our output. And it would depend, the output would depend on your input D. Okay? So, let's say we start with Q is equal to 1. Okay? So, it will be here. We start at Q is equal to 1. And then, negative edge triggering at 1. What is D? D is equal to 1. So, it remains 1. Then, find again another negative edge. This one. Negative edge, D is equal to 0. So, it goes down to 0. Then, negative edge here. D is equal to 1. So, it will go up. And then, negative triggering here. D is 0. So, here, it goes down to 0. Then, negative triggering here. Okay. Then, your D is equal to 1. So, it goes up. And then, negative triggering here. Your D is already 0. So, negative triggering, D 0. D implies Q 0. Okay. Then, negative triggering. Your D is equal to 1. So, you have 1. Okay? So, that will be our timing diagram for this particular symbol. However, if instead of using preset, we use clear. Again, clear should be equal to 0 because we're using the low, preset, and clear. So, clear should be 0. Then, our initial Q here will be 0. And therefore, our Q here will start at 0. Okay, so here, mag-start na siya at 0. Okay, and then negative triggering, this 1. Then, it will move up here. Okay, so the difference now will be this one and this one. Okay, so that's this one here. We use the preset. Here, we use the clear. Okay? And, of course, your Q bar will simply be the opposite of your Q. So, if we are using preset, again, nag-start diri, so your Q bar should start here. And then, that. Then, it will move up. Like that. Okay? Then, if we are using clear, of course, then since clear starts at 0, so your Q bar here will start at 1 and go down. So that will be your timing diagram if we have this particular symbol. Again, we make use only of one of the two conditions in your preset and clear. Whether we use the preset or we use clear. If preset, then Q will have initial value of 1. And if it is clear, then the output will have an initial value of 0.